All right, new day, new laptop to repair, and this time we have a Dell XPS 15. This is the 9500. This would be a 2022 version, has an i7 in it. And the customer said they turned it on and it heard a high-pitched pop. And they were guessing it was like a MOSFET or something that went out, but he wanted me to take a look at it and see if we can get this thing fixed up. So let's take a look at it. I haven't looked at it yet, so we're gonna look at it together and let's see if we can get this fixed. All right, let's see if it turns on. Doesn't do anything. Let's plug in the power. Okay, so it is negotiating at 20 volts. So when you plug in a USB-C charger, it actually turns on with 5 volts, and then it communicates with a laptop and then jumps up to 20 volts. So know that the PD controller on the motherboard is communicating with the AC adapter just fine. So that's one thing that's good, but it's not pulling any current at all. On the next line, you see it's 0.001. It's got moving around. If it was at least kind of trying to communicate or actually turn on the motherboard at all, like the EC chip, Super IO chip, was even trying to do a startup or even a power rail was coming on, you would see a little bit of current being drawn there just for a second at least, and we're not seeing anything like that. So this laptop is completely dead. Pressing the power button, it doesn't do anything either. So we'll need to open it up and take a closer look. So let's do that now. This uses a T5 screwdriver. There's 8 screws on the bottom. All right, these bottoms are very hard to get off, and if you're not careful, you can end up breaking something internally. You have to kind of get a plastic scribe right in the right spot. Pry across here and get it to pop open. If you try to use your fingers, you may end up cutting yourself because this bottom cover is metal or aluminum, and it has a sharp edge on it. All right, so we're getting it pried open a little bit. Should be able to pop it off now. Okay, and the bottom is off. All right, let's take a quick look around. Got the main battery here. This is a Dell OEM battery, has a serial number on it, so that's good. Here's the hard drive. That's a 2280. I don't know the size, but that's the heatsink on there. Got a pair of memory sticks. There's a pair of cooling fans. So in this model, this is USB-C only, so it has 2 USB-C ports on this side, 1 on this side. We plug in the charger. We'll see that it activates, and voltage is going to come through here. There's a couple of chips before it gets over here to the main power rail. So this coil right here is on the main power rail. Here's the battery connector, and so the main power rail on this machine, I believe, is going to be 13 volts. Might be 12.6 volts. Battery voltage is 12.6, so it could be 12.6. And so we can actually test that real quick. Let's get our voltmeter out. And let's see what we're getting there on the main power rail. Let me find a good ground. The measure right there, we're getting 0. Okay, so we're not getting anything on the main power rail. But this, let's get under the microscope so we can look a little closer. Okay, so the voltage comes in through the USB-C port right here, and it's going to come down this way. That looks like it might be the USB-C, the PD controller chip, so we know that's working. And then it's going to go to one of these chips. There's 2 ports over here, so there's 2 chips, and each one of these is going to handle the 20 volts coming through it. So let's measure and see if we're getting our 20 volts here. We'll just check on the output. So we're getting 20 volts in the output here. So 20 volts coming through here, and that's going to come over here to where the main power rail is produced, where it takes that 20 volts and reduces it down to the 12.6 that's going to run the actual laptop. I have to take this heatsink off so we can look underneath that. All right, the heatsink is off. So here are the 2 MOSFETs. So on this MOSFET, you're going to have on one side, you'll have 20 volts. On the other side, you should have the main power rail's voltage, which is at 12.6. So we'll measure on one side. We got the 20 volts. On this side, we should have 12.6. We do not have anything. And this is the gate pin. The power management chip is going to be controlling this gate pin. So the way a MOSFET is it's really just a switch. It allows current to flow through it or not flow through it. And so you have 4 pins on one side, 3 on the other side, and then you have a gate pin. And so on this one, they're actually going to be pulsing the gate pin, and that will make it where there's less than 20 volts going through because they need to turn the 20 volts into 12.6. So it sounds to me like something did explode. And so we probably should pull this board out so we can examine it and look for something that had actually burned up. Because at this point, you know, we're looking here at these MOSFETs, you know, this MOSFET looks fine, but it's obviously not turning on, but it's also not getting the signal because we see that gate pin's not getting a signal. So we know that it's not working. And we don't even need to check any further because further down the circuit, this is where it powers all the rest of the power supplies on the motherboard. And if the main one's not even getting produced, then we don't even need to look further. So let's pull this motherboard out so we can take a look around and underneath the motherboard and see if we see anything that has popped. Here, before we take this totally apart, let's look and see how much voltage we have on the battery too. I want to look at that. We got 0.4 volts. Now the battery's off. Let's do a CMOS reset on this before we take the whole thing apart because, I mean, sometimes it could just be a frozen bias. So we're going to unplug the CMOS battery. I don't want to get too far into this. So we're going to unplug the CMOS battery. With no power in the system, we're going to hold down the power button for, I don't know, 10 seconds or something like that. We just need to discharge all the capacitors in the motherboard. And then at that point, when we plug this in, it should automatically turn on because it's going to be in a CMOS, cleared CMOS state. And I see that's not doing anything. Well, it hit 0-1 for a second. We're getting the main power rail now. We're still not getting the main power rail, so CMOS reset did not work. All right, let's continue taking the motherboard out. I should have done that first before we started this, but. All right, and the motherboard is out. So let's take a look around on this motherboard, see if we see anything obvious first off, and then we'll continue testing. If they did a pop, if they heard a pop or a hiss and a pop, then we're gonna see something. Sometimes you can see a melted area. I'm just gonna pull this whole thing off. That way we can access all the circuitry underneath. All right, let's get under the microscope and we'll just kind of take a look around. All right, so we're looking for something that's burnt, discolored, looking for a spill even, something broken. So you let me know if you see anything. We'll go kind of slow. Here's a couple MOSFETs. Here's a couple MOSFETs. This is what produces the 3 and 5 volt power rails for the machine. There's the EC chip. It's kind of the startup chip. There's the BIOS chip. Just looking around, looking around. That's the power management chip. That's what controls those MOSFETs we were talking about that produces the main power rail. And this MOSFET is working with another MOSFET on the other side of the board as a pair. But it's on the opposite side of the board. Okay, over here, that's just another BIOS chip, but it's for the USB-C controller. All right, so a lot of this circuitry is going to be on the opposite side of the CPU and GPU, so this stuff's going to get a lot of heat, and so it would be kind of easy to have a component go bad, like a capacitor. So we can look for cracked capacitors. So these things are all the capacitors. Sometimes you'll see like a little hairline crack in it or discolored. But everything looks good. Based on the sound or the description of the sound, I would suspect that I would see something kind of stand out, but I don't see anything right this second, so. Okay, we're gonna have to take the heatsink off because I need to be able to see underneath this. It might be in the GPU or CPU vCore. Okay, so we're down to the bare board, and if you can see anything, let me know. This is the GPU. It looks like an NVIDIA. Let's see if this is a 9520. It's probably a 20 series. Could even be a 30 series. Maybe a 3050 Ti or something. And this is the i7 CPU. Let's take a closer look on the board. Don't see anything. Ah, there it is. There it is. This looks like this is a capacitor here. So this capacitor looks completely burned up. It would make sense that it was making a hissing sound because this is on the 19 volt power rail. This is the CPU V-core, so it's going to be running at like, 0.8 to 1.2 volts. So assuming this thing is completely shorted out, let's check. Let's see if we have a short across that. So I'm going to put this in continuity mode, or it beeps when I touch the probes together. And we do have a short across that. So this capacitor is shorted out. Now, did it end up damaging this chip too? Did it damage the CPU at the same time? Or did that capacitor get damaged from that MOSFET going out or something like that? So the first step I want to do is I just want to remove that capacitor and let's see if this short goes away in that area. Because it's tying this trace to this trace, so one of these is supposed to be a ground and one of them is supposed to be the positive. So let's just get that removed and then we'll do some more measuring, okay? So I want to be careful because he has this LCD connector here, and it is tiny. I'm going to put a little Kapton tape to protect this LCD connector. We don't want it to get damaged. I'm also going to blow the air away from it, but we want to be mindful of it at the same time. And we're not going to be in here for very long. Capacitors should come off pretty quickly. And you know what? We could actually just use instead of using hot air, we'll just use our soldering iron. There we go. Got it off of there. Look at the rest of this off the board. I'm going to add a little bit of solder to it. By adding a little bit of solder, it helps the other solder flow better. Because I have lower temperature, lower melt solder. Yeah, the bottom of that capacitor is still attached to the board. This whole thing is like the bottom part of this that got ripped off. There it is. It's pretty gnarly looking. But we still got to get this off this board here. I think I'm going to have to use some hot air, unfortunately. Maybe I'll use it in combination. Doesn't want to come off. Starting to move. There we go. Got it. Okay, let's clean that up. Okay, are we placing bets? A lot of the solder mask came off when I did that just now. It was really stuck to it. It was almost like bonded to it. We can add more solder mask here. It's not really a big deal because this is all one pad here and that's all one pad, so we're not worried about it. But this is one pad to here. So this is not, there's no copper behind any of that area. So, but let's check across there and see if we have a short. Did we place bets? Down below, come on. Is the short gone? Here we go. I see the short gone. I'm going to measure it both ways. It's saying it's still there, and then it's gone. The reason why it's doing that is because I switched the probes, and so it's putting a current through the board, and it has to fill up the capacitors. See, when I flip it around, it says 0 again, and then it filled back up again. And so once the capacitors are filled up on that, then it stops. Okay, so the short is gone. So now the first part of the bed is there. Now let's see if it turns on. We're going to replace that in a second, but it will turn on without it. That's not a big deal. We just need to figure out if the power management chip was detecting the short properly, and that's why it wasn't allowing that first MOSFET to come on or to produce the main power rail. It should automatically start pulling current immediately. So that's what we're looking for. So keep an eye on the meter here. 3, 2, 1. Port 02, port 03, 39, and the CPU and GPU are getting hot. So that capacitor exploded, probably because of heat. The CPU uses a lot of power, and it has 7 power stages powering it. So, I mean, there's a lot of heat being generated here. So let's look back over here real quick. think this is even just a startup one. Yeah, it is. So if you look at all the rest of these stages, so these are all kind of working together. And you see how they have the 4 capacitors, then 2, then 4, 3. But they have these big ones here. This is a small one. This, I think, is like one of the starts up the CPU. Just kind of the low voltage or the lower frequency. So it doesn't actually require as much, but it would make sense because he said right after he turned it on, it started making that noise. So let's replace this capacitor, and then we'll reassemble the machine and test. Okay, let's go ahead and prep the pads here with fresh solder so we can install the new capacitor. Let's make sure we have our air on for safety. All right, we got our new capacitor here. The new capacitor is installed. Just gonna touch it up a little bit. I just want to make sure we have enough solder on here to make sure it dissipates the heat. Okay, good. That's on there good. Okay, we have the new capacitor installed. Let's check it one more time. Make sure that it's drawing current before we assemble it. All right, 0.02, 0.04, and the CPU is getting hot. Ouch, ooh, that's hot. Okay, let's clean off this thermal paste. We'll clean off the, put all new thermal paste on the heat sinks. We'll clean out the fans. We'll get all this like new, and we'll get it reassembled, and then we'll do a test. All right, CPU and GPU are clean. All right, the heatsink is on. Let's get it installed in the machine. We got to put the back cover. We got to put this cover back on too. Okay, we'll install the fans. Okay, the motherboard is in. Let's go ahead and give it a quick test. Oh, we got the Dell screen. So that's good news. Let's see if it actually boots up, because there is a chance that that capacitor was just a symptom of what happened, not the cause. So the fact that that capacitor blew up doesn't mean it was just a capacitor that blew up. It could mean that there's something else that caused the capacitor to blow up. So I feel a lot better if it gets past this Dell screen right here. But since it is the first time booting up, it's going to take a little bit of time. So we'll have to wait. All right, it's just sitting there at almost 6 amps. Usually a boot up process should go up and down. It seems like it's just kind of sitting there. Oh, okay. It flashed something on the screen. All right, got a Dell screen again. 2 amps this time. All right, so secured with Dell Bio, or secured with Dell Safety, and there we go. We got the set time and date screen. Let's go into the BIOS. Want to see if it's charging the battery. Because remember, the battery is measuring 0 volts, but it's probably because the system was detecting a short, and so it's shutting it off. So we have primary battery. This is interesting. Primary battery doesn't say anything. Battery level doesn't say anything, but charging state in excellent health. So half the information is missing here. So I'm not really sure why. Let's put it into Dell Diagnostics, and let's see if we can see a little bit more information about this battery. We could have a bad battery, or it could be the battery is just so low on voltage because it's been it got shorted out because of that capacitor that it's not able to register properly. All right, health. Okay, so battery percentage is at 1%. So I'm assuming it was registering below 0%, so it was just saying it didn't know anything. So it's now battery's at 1%, excellent health. Before it was at an unknown status. The battery voltage is now at 11.5 volts, and it has 3 amps going in. It's detecting the charger just fine. I'm going to unplug the charger. I want to see if it will run off the battery. Sometimes when you have a short on a capacitor like that, it could cause an issue with those MOSFETs that were protecting the laptop. So let's see if there's any issues with those protection MOSFETs. And it's staying on just fine, and it's charging off the battery. I mean, it's running off the battery just fine, just charging at 3.3 amps. Now we'll plug it back in, see if it switches back. And it's holding at 0. Is it going to start charging? Staying idle. It should switch back to charging. Hasn't done it yet. Okay, there may be an issue. Uh-oh. Oh, okay, so switch to charging. Now we got 3 amps going in. Okay, whew, that was a close one. All right, so let's run a full diagnostic on it. I'm going to run a GPU stress test, a CPU stress test. I'm going to run the Dell diagnostics. I'm going to make sure everything passes before I get this back to my customer. If you have any questions or comments on this repair, leave them down below, and thanks for watching.
I saved another laptop.